Okay, so let us continue with our seminar. We are now on part 4 of the seminar. So here, what do we see? We have here a slide that shows us a possible advanced gray water treatment system, no? Where you would see here a symbol for the washing machine area, and here a dishwashing machine. Okay, so you have the fluents there, and then of course here you have from the bathtub or from the bathroom, so you also have gray water, no? Then it goes to your septic tank, and after processing of the septic tank, okay, then the output or effluent would go to a sun filter. So this was what I was talking about earlier in few slides earlier, no? So the sun filter will do the necessary filtration through what we call slow sun filter or gravity filter. Then you have here the next stage, which is usually I would call it the gray water tank, but here it is described as the pump pit, where there is a small pump, or a sump pit, no, and there's a pump, and any overflow will just flow to the drainage. But the water here can be used to water your plants. So here is a planter bed where you have plants here, and usually we select plants that has the capacity to add additional filtration capacities, like for example reed plants, no, like bamboo and some other equivalent reed plants, where their roots are very much capable of further processing this gray water. And then after that, the treated gray water will then be absorbed by the groundwater. It's already treated, and of course not possible for drinking, but it can already be passed through the groundwater, no, since it is being injected at the top of the finished grade. Then additional filtration will be done by the soil itself before this water would reach the water aquifer. Okay, so here is a system that is a possible way to utilize gray water. What is not indicated here is the possibility of using this gray water from this tank for flushing the toilet. So depending on how capable or efficient your sun filter, because you can still improve the effluent or the gray water quality by adding, say for example, a carbon filter. And you can also add, say for example, UV ray. So you can expose the water to the gray water to UV ray, and you can even further add chlorine to disinfect the water, and therefore it would be much sure that it is a clean water already, that can be thrown to the plants, and then could be absorbed by the surface of the earth. Okay, so let's proceed to the next. Here is another slide that again show you such kind of system, where you would see the rainwater here, okay, would have two stages, no? So the first stage would just impound the dirty water here, like the dirts, and then the clearer water would transfer here, and it would go to this life rain filter. It's the brand name of this product, no? But you can also provide any kind of filtering available, like the one being provided or offered by Emerald Pipes. They already have a kind of rainwater filter. Then it goes to an underground tank modules, no? And of course you also have a small pump here, so that you can still pump the water, okay, if you want to remove the dirty water and the basement of the tank, no? Okay, the clearer water would then overflow and transfer to this additional module. And in here, there is a possibility that it can be injected to the water aquifer. Okay, and this one is extended to the top of the surface of the finish grade, so that you can do necessary servicing on this well. So meaning to say, this kind of system, the rainwater is filtered or processed, and it is injected to the aquifer. Okay, so you can also pump it out here like this one. Okay, so you can reuse it. So in other words, if you do not collect the rain again, it will just go to the creek, to the drainage, to the creek, to the river, to the lakes, to the Pasig River, and to the Laguna Lake, or to the not Laguna Lake, to the Manila Bay, and to the China Sea, or to the ocean. So it's gonna be wasting this rainwater. Okay, here is a bigger picture of how we could probably well, in this it is how to prevent flooding, no? So it shows here of the rainwater that could be collected in the upstream of the mountains there, no? And it would be held in through point A through a dam. So without this dam, again, the water will just flow to the, let's say, to the sea, okay, to the rivers and to the sea. So point A is a means of controlling it, okay? And then you have here point B, where it is a source of storage, no? It's a storage area. So any overflow will store water in this area here to hold the excess rainwater. Any excess will just flow, okay, through here, point C and point D, and of course point E. Now with this kind of system, definitely it will reduce flooding of the urban centers, no? So let's just go over these points, no? Control the water level, build a dam to trap this and store water and release it in a controlled way. A dam can also be used to give electricity. Yeah, that's true. Build pumping stations. When the water level rises, you can pump water out into the temporary storage basins. Okay, then to build barriers, build up to the banks with earth or concrete to make embankments to keep the water in, no? Build flood walls around build up areas to keep the water out. Okay, that's another one. And here number 3, after the river's channel, straighten it. This will speed up the flow of water to the lake or to the sea, so there is less chance of a flood. So this is similar to the Mangahan floodway. So the Mangahan floodway was built during the time of Marcos, President Marcos, to lessen the flooding of the Marikina Valley, especially Marikina area and Pasig area and Cainta areas, no? With the Mangahan floodway, it allows for the emptying or reducing the overflowing waters of the Marikina River to the Laguna Lake. Okay. Now, next, widen and deepen it. No, you can dredge, let's say, rivers or the lakes, in order to be able to increase the capacity, no, the volume of retaining volume of such bodies of water, the lake or the rivers. Okay. And what's next? Here, which is the best way? There is no perfect way to prevent floods. Each has problems, and many fail to make the best choice. You must consider how often the river floods heavily, how much damage it can do, how much its method would cost, how much you can afford to spend. Okay, and number 4, of course, control land use around the river. So, like for example, the bank of the rivers should not be used for housing, because if there is flooding, almost always the banks of the river will get overflowed with flood waters, no? Okay, another thing is stop people building under floodplains. And of course, plant more trees in the drainage basin because the roots of the trees will hold water. Pay farmers to allow their fields um, along the river to get flooded. That means less flooding somewhere else. Okay. Okay. So this is one way of helping make it sustainable by holding the waters upstream and also generate electricity and provide for irrigation. So with this, okay, and of course, lessening flood in the lower urban areas. Okay. Now we go to a very economical and advanced, efficient system. This is the constant pressure VFP type off-feed system. No? So a kind of water distribution. It makes use of the willow pumps, a German technology. Okay, in this drawing you would see these three pumps equal in size, and they have the capability to operate at variable speeds. No, in other words, they would be running, say for example, from 1 revolutions per minute to, let's say, 1,800 revolutions per minute. So now the speed would depend on the volume of water that is required or the pressure that is required in the upstream. No, how is this being used? Okay, so here is a building. Okay, here is a building, multi-story at that, and you would see this kind of upfeed variable frequency drive pumps here. Now there are three sets of each. Each set is designated with at least 3 to 4 floors to supply water with. No? Of course, you can have only one set of this supplying the entire building, but of course, the pressure at the topmost floor as compared to the lowest most floor will be much lower, you know, here than the pressure here. So the only way for you to do such is to provide a pressure regulating valve for if you're going to use just one set of pumps. No, so here it uses 3. Okay, so in the conventional system, it make use of, here is the conventional system, just to compare it with that very efficient upfeed system. The conventional system has a cistern or tank at the basement or at the ground floor. Here it is, this red tank here. And then it has also an elevated water tank, this one here, at the top of the building, at the penthouse. Okay, so the system works like this. You have 2 pumps. One is a running pump and the other one is a standby pump. And the water from the ground cistern or underground cistern water tank will be pumped or transferred to this upper tank at the roof deck. Then after that, it will be distributed to the different floors here. No, say for example, this is 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1, say for example. It will be distributed by gravity. So the water will just be allowed to go down and this supplied to its floor, to the faucets, to the shower heads, to the kitchen sinks, and so on and so forth. Okay, so that's the conventional system. The conventional water supply system designed pumps up water to an elevated tank at the roof deck and delivers to the faucets, shower heads, and water closets of the building by gravity. The energy consumed, therefore, for say a gallon of water from a faucet at the second floor would always be equivalent to the energy used in bringing the gallon of water to the elevated water tank. So the energy that you use to wherever you bring the water, say you want to bring water to the 5th floor, you always have to bring it first to the topmost floor, to the roof deck, and allow it to flow to the 5th floor. You want to supply water to the 2nd floor, again you bring it first to the top floor, to the water tank here, and by gravity to the 2nd. So always the energy to consume will always be to bring the water to the roof deck. So it's very expensive. While in here, you don't need a water tank at the top of the building anymore. You just need the water tank in the basement or the underground tank, and just bring the water up to the location that you want to supply water with, like in the topmost floor, say for example the shower head there, or kitchen sink, or whatever. So the pump will just run. They are controlled by a pressure controller. So the one of the pumps will run faster, no, just to deliver that water. If more faucets will be open, then the pump speed will increase, no, automatically by itself, because it has this controller, a variable frequency drive controller. If ever there will be more faucets to open, then maybe the second pump will now run also, but not immediately at a high speed, at a lower speed, and depending on, again, on the requirement of pressure and the number on the faucets upstairs, then it will adjust its speed to deliver such kind of pressure. So that makes the water delivery very efficient. That's why we call this constant pressure, because of that sensor, pressure regulating device, will input always the present pressure in the system, and therefore adjust the speed of these pumps or motors to be able to deliver. If lesser and lesser faucets or shower heads are open, then slowly these pumps will also reduce their speed, just to maintain the necessary pressure corresponding to the number of faucets or shower heads or valves that are open. In one installation in Cavite, that building used to pay the utility company 60,000 pesos before they used this system pumping. After adopting this kind of system, their electricity bill went down to 12,000. So you could imagine the reduction in the energy cost from 60,000 to 12,000. It's about 80% of the cost or the energy consumption. So it's very, very efficient. Okay, so that's it. Let's go to the next. Here's another picture of that system. In here, I had a project several years ago in 2014, and I used 4 pumps, 1.5 horsepower each. This one is the bladder tank of the system, and this is the variable frequency drive controller, and it has this blow up controller, which indicates the necessary data of the operation of these 4 pumps. No, 1.5, 1.5, 1.5, 1.5 horsepower for a total of 6 horsepower. This system replaced the old design, which uses 2 units of 10 horsepower each, meaning to say 2 times 10, that's equivalent 20 horsepower, while this one only uses 4 by 1.5 or 6 horsepower. So in here, it is less than 1/3 of the capacity of an existing of the old conventional design. Okay, so let's just read this. A constant pressure VFD motor driven pumps consumes energy just enough to deliver water to the number of faucets, shower heads, water closets that are operating at any given time. A programmable logic controller (PLC) automates the operation of the stage operated pumps. Its variable frequency drive or VFD motor operate from 0 to 60 Hz or 0 to 1,800 revolutions per minute, depending on the operating water pressure of the system. The motor speed increases proportionate to the increase in the water pressure or the water demand. Okay, so that should be very clear that this Willow pump system, German technology, is very advanced. I know there are already equivalent of this. I think there is already I think ground force model and some others already, because this was introduced over 6 years ago. That means that other brands has already made their equivalent equipment for this kind of pumping system. Very, very efficient. Okay, now we go to life safety, fire and life safety. So here I'm showing uh, a 3-story building. Well, it could be 6-story, it could be 10-story, it could be 12-story, it could be 15, 18, and so on and so forth. Now the idea here is to provide here this fan. This is a fan at the top of the building. This fan injects fresh air to the stairwell if there is a fire. The moment you have a fire, and the fire will create smoke, and so as not to allow the smoke to come out of the fire exit, you have to have this stairwell pressurization fan. So it will automatically run, automatically started by smoke detection alarm system. Automatically it will inject fresh air, so therefore the smoke coming from here, from the rooms that are burning, will not be allowed, will be prevented by the higher pressure of the inside the stairwell. So every time the exit door opens, it will prevent it. I mean, the pressure will prevent the exit of this smoke, thereby allowing the exiting personnel to run for their life to outside of the building. Okay, so but of course you have to install a pressure controller. You have to control the speed and the running of this fan, the pressurization fan, so as not to over pressure here, because if you over pressure here, say too high, it will be very difficult to push the exit door, the panic door, the bar of the panic door, for an ordinary person. So it must just be enough. Usually the setting should be about from 3 psi to 5 psi above the ambient pressure. Say for example 15 psi is the ambient pressure. Your pressure here at the stairwell should be at an average of 3 psi over 15 or 18 psi up to, let's say for example 21 psi. So no more nor less. Otherwise, if you do not use this variable frequency drive, you're going to use this relief lower, which is mechanical in nature, very difficult to control. There's no way of easy calibrating this kind of controlling the pressure. The best way today is by the use of variable frequency drive. Of course, this BFD, of course, is also a very efficient way to run the pressurization fan. Okay, so this is not only for efficiency but also for safety. Okay, now let's go to the next slide. Energy saving via inverter type aircon. Of course, the inverter type aircon is now very popular. Almost maybe about 30 to 40% of offices already make use of the inverter type. The inverter type air conditioners is a variable frequency drive mode to maintain a constant temperature operation. 60 Hz alternating current is converted to direct current and then inverted back to a pulse width modulated varying frequency alternating current, creating an almost constant temperature control as compared to the cycling on-off operation in the conventional air conditioners. The differentials between the cold and hot conditions of the systems explains the efficiency of the inverter type air conditioner. Okay, so there is a slight reduction in the consumption of this type of air conditioner, meaning the BFD type, the inverter type, as compared to the conventional, because this one has a soft starting, soft running and soft starting, not like the conventional one, which is just it runs or stop, so it is not smooth. Of course, this one also, the inverter type also have a longer life because there's no longer the starting the big starting current of the ordinary type, or there is no more the surges in the current starting. So that's how this system works. Very slight, not so big in savings, not so big, okay? Now this one, another air conditioner type, which is the solar aided air conditioner type. It has a device added to the condenser outside of the air conditioning unit. It makes the air conditioner, the ordinary type, a little bulkier because of this um, uh, additional solar collector here. This one is the additional solar collector. Of course, this one is much more efficient than the inverter type. This one could have could reduce the consumption by as much as 60 to 80% as compared to the conventional or to the inverter type. Solar aided air conditioners help in lessening the work of the motor driven Freon compressor. The heat absorbed from the sun is converted to increase the pressure to the compressed vapor that when expanded in the condenser would become very cold liquid refrigerant in the evaporator to produce cold air inside the room. The energy savings here is about almost 50%. In my experience, about 60 to 70. So that when the inverter technology and the solar aiding combine, the effective savings could be about 60 to 80% of the operating cost of the conventional type. Okay, so that's it. This kind of system is much more efficient. But of course, it is more bulkier, as you would see this solar collector that is added. It absorbs the heat from the sun. Okay, it's not the sunlight, not like the solar panel, but it is the heat of the sun, of the ambient temperature that is being absorbed. Okay, and here is a solar type air conditioner that it uses solar panel being injected directly to the compressor of the systems and therefore reducing the consumption of the compressor and the evaporator of split type. This is a split type air conditioning system. Okay, so that's another possible way by directly installing panels and injecting the electricity harvested from the sun to the consumption of the compressor. Okay, here, in regards to the maintenance of air conditioning units, we should be reminded that the filters of the aircon unit must be cleaned and replaced at least twice a year, or even thrice a year, as the case may be. Cleaning or changing the filters always make after the pollen season. Oh, that's in America, but in here, let's say during the hot months, no, let's say summer and let's say August, September, okay, October. The filters will be replaced with similar new ones when the filters reduces the airflow already, or you can wash the filters. A reduction in airflow increases pressure loss, and the energy used by the fan, it reduces the efficiency, heat recovery, and quality of the indoor unit. The heat recovery cell or this is removed and cleaned every 2 to 3 years. This washing liquid can be added to the washing water. Okay, more instruction and maintenance services can be seen in the manufacturer's manual of every type of air conditioner. Okay, here is another energy saving device. It looks like it's an aircon, but actually it is not. No, this is what we call the mechanical heat pump. Okay, a mechanical heat pump is a reverse of the compressor, the condensing unit of air conditioner. No, it makes use of the hot temperature of the warm air. So here, you can see this warm air passing through it, getting into the device, and on the other side already would come out. No, so this warm air, the heat of the warm air, the heat will be transferred to an exchanger, and here a cold water would be coming in there, goes inside, and it will be heated. No, the heat here is converted to heat in the water and transferred, so that therefore the output here will become warm water. So you can use this to preheat the water of your swimming pool, or you can also be used for your in your toilet and bath, for your shower, and some other purposes. So this kind of system is very much in use in big hotels and big motels, and it's a much more efficient way of preheating water, ambient water or cold water, before it is being used for, let's say, by localized water heaters in the bathroom. Okay, so very much more efficient. Okay, so before we continue on, let's have a break again.